auch auf Englisch gehalten, da wir auch viele Gäste aus Indien dabei haben. Bharat, the stage is yours.
Ja, ich bin jetzt alleine für nächste 40, 50 Minuten. Guten Abend, die Damen und Herren, meine Gießerei-Kollegen aus der Welt und speziell Aachener Gießer Family, AGIFA. Zuerst vielen Dank, AGIFA und Gießerei Institute, für die Gelegenheit, hier meine Gießerei-Werdegang zu präsentieren. Ich bin dankbar an alle ehemalige Kollegen, Johannes, er war dabei, Dr. Uwe Ruhmann, Professor Bürsch Polosek für ihre Zusammenarbeit während meiner Aachener Zeit. Ich erinnere die Zeit, wenn AGIFA Busenabend ist normalerweise sehr schön mit Abendessen und Getränke eingerichtet. Diese Corona-Pandemie und speziell neue Variante Omikron hat unser Leben geändert. Sonst hätte ich persönlich in Aachen gekommen und es wäre ein schön nostalgischer Moment für mich und für alle uns. Ich könnte heute den Fachgespräch über Gießerei in Deutsch gehalten, aber ich bin informiert, da manche Kollegen aus englischer Sprache teilnehmen. Daher werde ich heute in Englisch die Präsentation halten. Ich entschuldige mich für deutschsprachige Kollegen, aber ich bin ganz sicher, dass in die heutige Welt sehr international ausgebildet sind. So now switching to English, and warmest welcome to all colleagues from Foundry family and especially to Aachen. And my pre-Aachen alma mater, College of Engineering Pune, all professors, friends, I welcome all of you and would like to present my Foundry career along with some interesting topic I came across during my journey of Foundryman. Just wanted to request all of you to be just cautious about the presentation as I am now sharing the screen. You might minimize the videos and all the camera screen to see the presentation fully. So let's begin. Johannes, am I audible clearly to all of you?
Perfect.
That's clear.
Gite?
Yes, of course.
Okay.
Yes.
So, can you see the screen?
Yes.
Yes.
I'm certain everyone is wondering what is this title about, Aachen to Chakan. Aachen, yes, of course, everyone knows. Let's discover this curiosity together. Many of you are aware of one title or the other, and we will see how to make it more familiar to all audience. Here is the world map showing both location, Aachen and Chakan. Chakan is nothing but it's an industrial area located in Pune, city called Pune, which is 120 kilometers south to Mumbai. We can see how different both locations are, being on east and west side of the world and around 7,000 kilometers apart. One thing is common in both. They are renowned for their own products. One is education and another is industry. As we all know, Aachen is popular for technical university of diversified faculties, right from mechanical to medical and metallurgy to management. Comparably, Chakan is explicitly known for its engineering manufacturing hub, starting from OEMs like Mercedes, Volkswagen, the Indian car manufacturers like Mahindra, Tata, and tier 1 suppliers, Bentley, Bridgestone, to name few. Witnessing on the left-hand side takes me down the memory lane of beautiful Aachener Dome, icy cold street of Gisra Institute, and notable Super Say, and of course the experiments in Gießhalle. On the right, Chakan portrays excellent industrial setups of General Electric, Bridgestone, car manufacturers, and a small but remarkable foundry, Taural, India. So far, I hope everyone is now familiar with the both location. And now I will begin with my initial days as a metallurgist, trying to search a destiny of Gisra Institute. As all of us know, and metallurgical engineering at RWTH Aachen allows you to choose one of the faculty as a study major. As a keen metallurgist, it's tough to select one of the courses as all of them are the best at their own. Be it primary ferrous or non-ferrous metallurgy or process technology as foundry, metal forming, and many more. As many, I was also jumbled to choose one of it and finally found my passion towards foundry technology. Unfortunately, the course as a major was not available in English language. We, master student as a majority, approached Professor Burish Polasek, and he was kind enough to accept our request. This is how the journey started at Gisra Institute, Foundry Institute of Aachen, and continued. Thanks to all of you, I was told recently that more and more international students are joining this Foundry as a major course and enjoying it. So fondly, I was enjoying my research assistantship at simulation department as part-time job. And in continuation, Dr. Berger, Dr. Bjorn Pusta suggested me to work further on a topic of influence of melt preparation on porosity formation. The first long assignment developed a real foundryman in me, fascinating to stay late evening to perform field trials of melting tiny 405 kg aluminium in laboratory furnaces and pour it by myself, placing the thermocouples and recorders. This was a dual satisfaction for me as a self-simulating results were getting verified at real world. Honestly speaking, what else can be so rewarding for a passionate student to give a practical input in simulation software to correlate 100% matching outcome. For example, the first casting block had a micro pore. I will just switch on the marker here, the laser pointer. So this was, can you see the marker here, red marker or pointer?
Yes.
Okay, so this was the experimental setup. Olive green color, central part is the casting block, and side two long green are the chills, cast iron chills, and the base blue color is also the base plate for the chilling effect. On the right hand side, shrinkage porosity in the central part of the casting block. And we have got the same here, a micro porosity, which was corrected by reducing the distance between the base and side chills, as well as lowering the pouring temperature to get the read of hotspot in the central part. The melt preparation we have done in a 3-4 different formats in the preparation. The first one was the clean melt with argon to avoid the contamination of hydrogen and oxides. The second one, normal melt without any treatment. The third one is the more impure, dirty melt enriched with the hydrogen and oxides. Now, we have got here all the analysis at the metallurgical lab, getting the microscopic analysis, having the electron microscope results, seeing all the micro and macro porosity, as well as comparing the solidification curve from the simulation, MagmaSoft simulation, to the practical and the actual ground results. We came to a conclusion which is, for today's world, for me, it's very basic, but it was mini thesis. So as we say, it's a beginning. A conclusion, and honestly speaking, as a foundryman, it is still helping all of us. High hydrogen gas content leads to higher gas porosity, it is clear. Number of pores in casting increases with the high amount of oxides. So of course, the porosity formation will automatically lead the precipitation of the aluminum oxides, and the brittle phase will form. Gas porosity is desirable sometimes to compensate the volume shrinkage. As all of us, we know, locally at some area, we want to have more gas porosity to compensate the shrinkage porosity. High temperature leads to the high hydrogen content in the melt, especially after the 660 degrees Celsius. Last, the hydrogen gas can be reduced with the argon atmosphere. Further, a desire to work in industrial setup has brought me to an interview at Mercedes-Benz, Stuttgart, BMW, Landshut, Georg Fischer in Schaffhausen in Switzerland, alongside exploring the Europe for myself. Mr. Roman Gite, my guide at BMW Foundry, stated the problem at low pressure die casting of cylinder blocks and heads, having trouble of frequent change in sprue, keeping the idle time of few minutes, resulting into the lower productivity. We can see here the sprue after 100 cast or 80 cast, it was getting eroded, and they used to weld it or they used to replace it. That replacing time was keeping the machine idle. The topic says, we have compared the thermal stability of different materials and coating for permanent mold in molten aluminum. My internal guide at Gite Institute was Diploma Engineer Christian Oberschelf. Further, a sprue having wear was not able to hold the mesh filter. As we know that there is a mesh filter to get the melt cleaner, was not able to do that. And as we can see here, the EDX, energy dispersive X-ray spectroscopy, was taken to get the analysis of chemical characterization of the sprue, and it can be easily seen that or illustrates clear continuation of the melt as well as precipitation of aluminum on the steel material. So next slide is the how we have developed that experimental setup, and how was the experience. Master thesis topic was an experience in itself, developing a comprehensive leader in me to execute the project from scratch to conclusive statement. Along with my guide, the selection of different materials and coatings, design of laboratory setup, outlaying the prerequisites, inviting vendor for quotation and doing price comparison, installation and commissioning, to dealing with the shop floor people to get the few trials were managed by me, and this whole phenomena evolved a manager and widened my horizon to think as an independent leader. As seen here, a trial-based small crucible here, trial-based, this was the schematic diagram, the design, and here is the practical experimental setup at one corner of the BMW Foundry in Landshut. We have developed this rotary system to spin the standardized at the standardized rate to get accelerated result of mechanical and chemical reaction of the melt to various materials and coatings. Both static and dynamic spinning resulted into the different level of erosion. Here we can see all the different materials of the die steel, different coatings, very high ended material like stellite, cobalt-based tungsten were used and compared. And here we can see this is like a sprue life up to 1,000 shots, and on the picture giving the spinning in the melt, and left hand side were some metallographic analysis to see the intermetallic phases of the contamination. The conclusion for this whole trials was the higher the temperature, more is the dissolution of the DIN 1.23 material in the melt above 750 degrees Celsius. I still remember the rotating DIN 1.2343 was totally dissolved when it was getting rotated. Molybdenum and tungsten are excellent erosion and corrosion resistant material, but they are very expensive. Titanium nitride coating gave a better wear and corrosion resistance against aluminum oxide, and its combination on hardened DIN 1.2343 substrate is the best commercial choice. This whole methodology has given opportunity for BMW to develop further much more systematic approach of quantitative and qualitative investigation of the influence of the molten aluminum on different materials and coatings. I'm proud to mention here that till today, BMW is using the solution of titanium nitride coating, resulted in enhancing the sprue life from 80 to 500. So basically, after the BMW time, I found my first professional career job at Mahle in Stuttgart, and proud to mention in front of all Aacheners that right from the Professor Juncker being the CEO, global CEO of Mahle, till the group leader and the colleagues like Ben Salai and Mahesh Doga, all of them are from RWTH Aachen, that to Gite Institute. It was like a family feeling for me to work with them. The impurities, I got the first assignment at Mahle GmbH in a process development department to play around with the melt quality. And as all of us know, the impurities like oxides and hydrogen content were major concern, as piston is most critical in engine, being human life associated with it. My early days at Mahle in process development department provided me an opportunity to work in depth to molten metal quality. Foseco Germany introduced the product to measure quantitative hydrogen content in molten aluminum, and this was in 2006 or 7. The product is called Alspec H. It is built around an innovative electrochemical sensor that is capable of rapid and real-time measurement of hydrogen. Having the base of ceramic material, calcium zircon oxide, it has got the two different electrode. One is called reference electrode and the other is called measuring electrode. We can see the schematic diagram here in this area where the probe is deep in the aluminum melt. Hydrogen solubility strongly depends on the temperature. Therefore, the melt temperature must be also measured in order to calculate the dissolved hydrogen level. And here you can see there are two curves. One is the hydrogen content and the other one is the temperature. And it was finding the correlation between the temperature and hydrogen content in the melt. This incredible instrument has supported me to test different shapes of rotor. You can see here, rotor head in rotary degassing, a diagram to show you how the degassing, rotary degassing happens with the purging argon or nitrogen as inert gas inside it. So to test different shape of rotor heads, purity, different purity of argon and nitrogen gases, degassing time, rotor speed, all this parameter has given me opportunity to get the optimum combination of all above to achieve the desired level of hydrogen gas in the melt, and Alspec H was giving me a quantitative analysis of hydrogen concentration. On the lighter note, the most exciting part was to add forcefully hydrogen by holding potato in the molten bath and giving a lot of gas inside. It has produced a lot of big holes on the aluminium surfaces. This is another area of the measurement of oxides and impurity inclusions in the molten aluminium. As all of us know, this is called PORFA technology, or the instrument is called Trefil, developed by ABB Instruments. Two simple steps here, sampling and metallographic analysis. Predetermined, we can see this one is the one instrument and this one is, there are two different instruments, and predetermined quantity of aluminium, liquid aluminium, is filtered under the controlled atmosphere, passing through very fine porosity filter here, and we measure or weigh the kgs which are going down. This produces a different kind of curve against the time and weight, which also gives a very initial indication whether the melt is clean or not. As the filter gets choked up, automatically you can see that there are a lot of oxides and a lot of inclusions, but 100% inclusions in the melt can be determined only with the PORFA metallographer, which is available with few companies in Germany. You have to cut this sample and send it across for the scanning electron microscope, where they will analyze the key residual pictures as well as break down the each inclusion type expressed in the millimeter square per kg of aluminium. So this is, we can see here also the melting furnace has got a lot of oxides and inclusions. After degassing, it will be reduced to the half. And here on the left hand side, one picture shows the PORFA metallographic analysis with the metallurgical spinel and in magnesium oxides. So amongst few projects I laid at Mahle, Stuttgart, during my 5 years of tenure, I would like to mention this special one. During 2007-8, the automotive industry accepted the challenging task of conversion of the Euro 3 to Euro 4 norms, and tier 1 suppliers like Mahle received new generation of piston design to cope up with more lighter weight and strength. This has given a new dimensions for the metallurgical engineering, and we can see, because of this different variants of left to right, you can see the cooling gallery is getting reduced and very small. This product has to run in million quantity, and agile action is taken place. As all of us, we know, the core used in piston is made out of salt. It's a cooking salt, NaCl, sodium chloride. For ease of the knockout, later we have to get it out also. Defects as blowholes were observed in the upper side of the cooling gallery, and a lot of efforts, root cause analysis was done, and we got to know that compressed air inside the salt core blowing at the last stage of the solidification and leaving some small defects in the upper cooling gallery of the piston. We have come up with 3 different solutions, making micro continuous grooves on the salt core, which is called in German Rillen, to accommodate the micro level of air and gas during the solidification. And it was also successful, not to the very perfect extent, but it was successful. Developing the coating to isolate the compressed air in the salt core and aluminium, molten aluminium. The third one is the numerical calculation of counter metallic pressure to suppress the hot air inside the core till semi-solid stage of the molten aluminium. This was something which I just thought during my one trip to the north side, that whether we can suppress this gas for some time, because there are only few seconds where it is getting evolved. So metallostatic pressure by increasing the riser or feeder height was also possible. But I have calculated those meters and the riser was going up to 15-meter high, which is impossible for us to design. And hence, I came up with the idea that external pressure will be put at the last few seconds of the solidification to suppress that air inside. It was 100% successful, but due to the technical problems, the serial production plant acceptability, we have finally gone with one of the solution above, which I can't mention. And finally, this solution was implemented at mass production plants in Saluzzo, Italy, and Krotosin, Poland. So this was something I really cherish as a project. And here, at this stage of 4th or 5th year of Male, I decided to do my childhood desire of becoming entrepreneur and started searching for breadth of technological gap in foundry world in India, and came across a company called Metallographic GmbH in Rastatt, Baden-Württemberg, doing green sand molding for aluminium casting. And I realized India, being second largest casting manufacturer for the world, is having only 8% non-ferrous castings. So this was a good lead for me to start green sand molding plant in India. And this was the first step to start my journey to Chakan or Pune. So far, I think everything is audible, Johannes. We came to the half part of it.
Everything is fine.
Alles klar, Florian. Thank you. So my first venture, G&B Metal Casting, has started in 2013 along with my hands-on experience in Rastatt, Metallographic Foundry. As operator like molder, core shooter, melting, pouring, fettling, and to the extent packaging and delivery too, the entire package to practice my future for India. Still remember those days of hard work kept me motivating by doing competition with the fellow molder to challenge on record break numbers. Hard times, but thanked million times once encountered the real problem on ground in India. As this organization, G&B, was a tiny, small venture with handful untrained workers. I still remember having flight to Germany that night, and one of the molding machine broke down early morning. I could not afford to have no production during my 1-week business trip to Germany. Today, amazed with those moments of opening molding machine like a maintenance guy and fixing it to the greatest satisfaction of myself. This was possible only because of the Rastatt days, hands-on experience. Here is the pictorial on the pictorial depicting the Rastatt foundry on the left-hand side, and right-hand side, the first foundry I started in India with green sand molding, having the jort squeeze machines, manual pouring, of course. And I would like you to see this video. Maybe the video will be buffered, but I hope you will enjoy it. This is the whole process of green sand molding, making the cope and drag and closing it for the further operation of pouring. So I will start it. Yes, I hope it was visual for you. What are the challenges? And I would say the biggest task for me, being in India now and having the experience from Germany, what kind of differences I have found. I have mentioned few of them here. Foundry fraternity as Indian Institute of Foundrymen is widely spread across demographic region of India, and they are helping out foundry industry to bridge the technological gap. And I became a member with them of their West region in 2020. The challenge I encountered as an aluminium foundryman are here. You can see it. The first one is though India, as I already mentioned it, though India is the second largest producer of casting, but the non-ferrous share was only 8%. Hence, constrained non-ferrous culture in India. Lack of technical universities providing fully foundry-focused courses. Limited resources of foundry equipments. Non-availability of special alloys like zinc content, namely Custador and Unifond, which are used for the medical applications. Angular and subangular sand availability with the lower content of silica makes it more coarser in grain and having the dust content. Import dependency on foundry products like modification, tablets, high density sleeves, foam filters, and etc. Scarcity of skilled manpower in aluminium foundry field. Rare sand foundries for aluminium alloys. The common process for aluminium in India is die casting. So there are many other different processes in die casting like high pressure and low pressure and gravity. Despite of all above challenges, India is getting aligned to new demand by introducing practical-oriented technical schools and adding new courses, contents in existing syllabus. Many international companies are bringing their technology to India, reflecting into the streamlining on non-ferrous knowledge. Here are the few products G&B Metal Casting was producing to export to sectors like firefighting equipment and power generator industry in Germany and the UK. Technological potential, before that, I just wanted to say these are the few products you can see here, the name of the product, the weight of the product, the alloy. Again, you can see from 4 kg to 18 kg from different alloys I was producing as raw casting. There was no other processes like further processes, which I will come here. Technological potential at G&B Metal Casting was at its peak. Customers appreciated the product quality and the disciplined process flow, which was learned at its best in Germany. Foundry processes were content to satisfy customer demands, but as you all know, customer wants to buy a technical solution at one-stop shop. The technological infrastructure for further processes like heat treatment, machining, painting, quality systems were missing, and as first generation entrepreneur, capital investment was the biggest challenge, and this is how the hunting for the right partner from Europe has begun. This is a small credential CV of myself, which I have put forward as a competency to get the investor or the business partner attracted towards India. I will not take much time because we have already talked about it. AGIFA has already mentioned it in the introductory mail. In today's trend, the investor located at Wall Street of New York are looking for more tech company startups than conventional industries like foundry, and very few will be interested in foundry with a huge investment, that too in India, whereas the Eastern Europe becomes more lucrative. As they say, every struggle finds its destiny. Dr. Pradeep Pawar from Siemens, Germany, introduced me to a giant German sand foundry located in Poland during GIFA 2015. And Taural India started to get shape. And this is a small picture from our foundry along with our people in 2014 or 15. This is what I call a transformation from a tiny, small components to a gigantic. G&B metal casting. On the left-hand side, right-hand side is Taural India. Casting weighing around 500 kg and 4 meter long in length, this difference can easily be seen as top right picture. The pouring ladle is becoming immensely huge compared to the human size here. And on the left-hand side, we were having a small ladle and the people were looking more larger than the ladle. Similarly, during G&B metal times, the mold was lifted with hand, whereas now it is carried on automatic conveyor because they are like few tons in the weight. Taural India is the state-of-art facility having done automation of usually traditional manual processes. I would like to reiterate, a lot of automation, usually manual process is being practiced. This was feasible due to one and only one, Mr. Lothar Thoni, as a third generation foundryman from Rhineland-Pfalz, and 40 years of tireless efforts taken for betterment of the foundry processes. I'm glad to mention here that our Indian entity is one level upgraded to Europe. So this is the location for Taural India. As you can see on the left-hand side, there are different neighbors, and these are the three buildings. It is located strategically in the central part of India, being 100 kilometers away from the famous Mumbai port and surrounded by all engineering companies from the world. A few adjoining company names are mentioned here, like Philips, General Electric, ThyssenKrupp, Bridgestone. This facility is built in a speedy time span of 1.5 years, having 22,000 square meter facility comprised of 3 different units of foundry, machining, and heat treatment. Heat treatment is also having this long building having the continuous booth for the fettling, radioscopy, then painting. So all Europeans as well as Indian statutory norms are strictly followed by installing the dust extractors as first in row to maintain the dust-free and healthy working atmosphere. What is special about Taural India? A salient feature about Taural India is, as we discussed earlier, customer demanded once to have one-stop shop. And same philosophy was followed by Toni Alutech in Poland for decades, expanding their processes like growing from sapling to a giant tree. Taural India has developed replica of a European plant in Chakan, Pune to cater all needs under one roof. It can be clearly depicted in this slide, right from the design simulation, pattern making, molding, pouring, fettling, casting inspection, radioscopy, heat treatment, painting, machining, and leak testing is being done in one shop. Here, I would like to mention about the radioscopy. We have a 2 digital radioscopy booth having a size in the height 5 meter and 3 meter and diameter of 1.5 meter to 3 meter. Similarly, heat treatment furnaces are having a basket size of 5 cubic meter can carry a weight of 10 tons of aluminium inside it for solutionizing and aging furnaces. Here we provided the first time in the group companies to supply ASME, American Standard Mechanical Engineering, Standard of Mechanical Engineering certified safety switchgear castings in assembled manner to American market. And this has added to our existing profile till leak testing. We are now giving the assembly also. The group caters customer base in diversified sectors like energy, power, mining, defense, marine, medical, robotics, transportation, aerospace. Most of the sectors we cater from the group companies. The motive behind formation of Taural India is our customer base spreading their wings across the globe to cater the developing markets like India, having more and more product demands. We followed them as Tony RWTH and started the plant in India, Mexico. We recently bought a plant in Germany also, CF Meyer near Ulm. Taural India has started its own journey in 2017. This is what you have seen is the new facility as phase 2, but phase 1 was started in 2017 to provide the casting to burning demand of energy market. To be specific, transmission and distribution sector. This is exclusive activity of import substitution to Indian government. Of course, we further develop the markets like defense, medical, transportation, and marine and mechanical engineering, to name few. Here we can talk first about the medical, railway, and defense market, as I would like to talk more technical details on the energy component. It might be interesting for our fellow foundrymen. We can see all intricate and quality demanding castings for medical sectors, that too with special material like Castatur. Here you can see there is an aluminium zinc material, so the Castatur material is needed. Most challenging work to meet the dynamic demands of the customer. Alike, aluminium gear case for Indian Railway is made out of the aluminium copper 4 alloy, having difficulties to avoid the crack in the casting due to the formation of copper intermetallic phases. Here, these are a few defense and marine products. This is the product. We are proud to mention that we developed above engine block, first time in history of India to manufacture the combat infantry battle tank for Indian defense. For our friends sitting across the world, it's interesting to know that the huge engine block of 170 kg has been made by assembling 32 cores together, and the whole mold was having a dimension of 3 meter to 4 meter into 2.5 meter as a dimension. Few ongoing projects for the naval engineering are progressing fruitfully. And this is where we come to our energy sector. Indian energy market is growing at a speed of 15% yearly due to high demand of good quality and uninterrupted electrical supply network. It is also due to a paradigm shift to renewable energy after Paris Summit in 2015, resulting into the change in kV ratings for substations. The rapid urbanization has increased the real estate price to the sky, and conventional T&D air insulating AIS substations need enormous space to lay down. Hence, India is rapidly shifting towards the GIS, gas insulating switchgear. This technology, to cope up with the scarcity of land, is something in availability in itself. every city is having a demand of metros, bigger shopping malls, conventional centers, commercial complex, airports, leading to the more electricity necessity is now this GIS, gas insulating switchgear, is very versatile technology, but challenging for electrical engineers as SF6 gas, sulfur fluoride gas, as a separator, as an isolator, is used in closed chamber to isolate the electrical conductors, otherwise with the help of air in AIS, conventional substations. SF6 gas, being poisonous to living beings, will lead to mortality. These enclosures are made out of aluminium casting at Taural, India, having the prerequisite of 100% helium and air leak testing. Here is also so-called bigger casting of 245 kV substation of Siemens worldwide, and this is being used in India from our location. I would ask a moment of last video here to watch the GIS substation showing all aluminium castings, these kind of enclosures and housings are made out of aluminium casting, and the pipes, which are called bus duct, made out of aluminium extrusion welding parts. So this is where we will start with. I hope it will be. I don't know what's happening here. Now it will be okay. So I hope it was visible for all of you. So I just stopped it because it continues. This is showing that how the from the infrastructure wise, the height can be reduced, how we can save the space. So Okay. So these all castings, as we say, the first article inspection, FAI, which need to be done to validate the casting parameter to sustain the design pressure of 7 bar. All these castings at their substations are comprised of SF6 gas at 7 bar continuously throughout the life. So what we need to provide, actually this is in general also the material certificate for the chemical and mechanical properties of the material, X-ray test reports, dimensional report with the ballooning diagram, as this colleague who is doing the ballooning diagram, 3D scan verification, pressure leak test, and burst test. The burst test is something which we will talk in further slides. So this is something standard list of documents as a quality system we have to give to the customer as metallurgical tests, non-destructive tests, CMM reports, ultrasonic test. This is the last slide I would like to present as a first article inspection. At the first development, we need to do the burst test of the sample, and on the upper right hand side here we can see the helium leak tester, and the same component of Siemens 245 kV is here. You can see all the openings are closed with the flanges, and through few flanges the helium leak chamber is vacuumized, and then the helium leak test and air pressure test is performed. This test 10⁻⁹ millibar liter per second confirms the stability of design pressure, where all components, 100% serial production components, has to go through the helium and air pressure leak test. Only the first few sample, they have to be bursted, and the burst test is the customer wants to validate their own design of casting as a wall thickness, whether it will sustain to the 5 times of the design pressure. So 7 bar is the design pressure and 5 times is the 35 bar. Usually our components, our castings, they burst at 70 bar and above, and sometimes the flanges come out because there is no damage on the casting structure. So this is possible only because of the casting methodology, state-of-the-art process, and the know-how made in Europe. Not to forget, our best friend Magmasoft from Aachen helps us to reduce our stay at Gießhalle at the casting floor. So I will play the first casting burst test. It is a 1.5 ton, and the next picture, as the last picture, will show this casting having myself and Mr. Tony in front of it. It is a 1.5 ton, 1,500 kilo casting, hollow casting. On the right hand side, it is 700 kilo casting for the American market for the DT to give for the first article inspection. Let's see the short video. So, vielen Dank. Thank you very much for your patient listening. Vielen Dank für Ihre Aufmerksamkeit. Und I will just, as I said, this is the biggest casting. So, Prost als Stolz-Gießer. And now I will stop the sharing the screen and come live here with a, can you see me?
Yes.
Yes. So Anstoßen, Gisrai, and Prost, cheers for the Aachen time. Thank you very much. Yes.
Wolf.
Yes.
Prost, money.
Zum Wohl. Zum Wohl.
Okay, so I hope you liked it and it was helpful as a foundryman to know about the journey.
Yes, thank you very much, Bharat. Yeah, very interesting, impressive talk. And are there any questions to Bharat, Gite, from the audience?
Yes, I have a question, Bharat. Toro speaking. Hello.
Yes.
How do you do all this engineering? I mean, you have so many different parts, like for defense and for medicine, and then for the energy sector that you showed. So you need a lot of know-how in designing and simulation and all this stuff. So how do you do that? Do you have your own engineering team,
Yes.
or do you have some services you use outside? Or
No, we have our, as I said, this is a small world as Taural India in India, but Tony Alutech in Poland is widely spread over 100 acres of area. It's a huge plant having a 2,000 metric ton good casting, machine casting every month. So they have 2 MagmaSoft simulation and minimum 15 to 20 people sitting in the Poland office. We also have here our design team. We are also developing recently a lot of components for L&T defense, for the Indian defense. So yes, we have a in-house team for all this development work.
okay. Bharat, I have a question on your competitors in India. So in this kind of business, is there a competition?
Yes, I would say up to 100 kg size and up to a meter or 1.5 meter size. We have a competitor, 2-3 competitors in India. But once it goes above 100 kg weight and from 2 meter onwards, we are the company who can produce such kind of casting.
Okay, so that's a monopole position. That's impressive.
Yeah.
So any further questions? So are there any actual students from RWTH in Aachen from India here in the audience?
Yeah,
Perhaps,
I'm from
yes,
India.
perhaps you have some questions.
So, yeah, I wanted to ask one. So hello Bharat. So I just wanted to know, where do you see the future for aluminum in India? I mean, are there any new arenas opening, like in other structural components, such as like in construction industry and stuff like that? So do you see scope of aluminum growing in that side?
I think yes, because if I see a lot of people, they are putting a lot of efforts and finance towards the decoration of the facade, and maybe because of the lack of foundries in India, they are actually placing something like a steel structure with a knitted, I would say, plates, which can be replaced by casting if we come to the market. As you can see, a lot of different sectors I'm busy with, but the civil and infrastructure is also something which I want to do it in future. I have seen a lot of amazing things. Lothar's father, my business partner's father, being at 82 years old, he is developing something like a grill, a compound out of aluminium, which will be excellent for the weathers like in Germany. Otherwise, they have to get the pencil and brush and all the time actually paint the corroded the compounds. So I guess it is having a lot of future and potential for young engineers like you to come to India and explore the non-ferrous field of metallurgy.
Thank you.
Yeah, some
Thank you,
further
sir.
questions from the future Foundry
Yes, Shruti.
women and men, Miss Mane, yeah.
Thank you, Professor. So, do you think that it was challenging?
We cannot hear you.
Oh, you cannot hear me?
Yes.
It's a little bit silent, maybe.
Yeah,
Maybe you
perhaps you
come
can speak a
nearer
little
to
bit
the
louder
mic.
or,
Okay. Can you hear me now?
yeah.
Yeah. So, was it challenging to switch to non-ferrous because in India, cast iron SG is mostly dominant, and it's more easier to have this foundry because the raw material and the investment is less than the aluminium because the raw material price is more. So, was it challenging for you a few years back? I just wanted to ask you this.
Yeah, you have seen my journey. It's challenging throughout the years, and today also. Every day is a challenging day. As you rightly said, maybe aluminium culture was missing in India, especially for the sand foundries. And it was challenging for me to start with maybe a 10, 12 people, and today we are having 500 people working for us. So it's a challenging journey of last 6, 7 years. From the investment point of view, yes, you are right. Ferrous foundries can be laid down and put on the ground in a lower investment. But the thing is, the problem is, the future is with aluminium, and I wanted to start with something which is future for India and for the export market also. And I can see now the aluminium inclusion in India is increasing. I don't know the exact figure, but what the world says is, for example, Germany consumes, don't go after my figures, I'm not a statistic person, but this Germany is using something like a 10 kg of aluminium per capita per year. India is using 1.4 kg or something. So it's nothing. So there is a huge potential which can be explored and future can be made.
Thank you, Bharat. Maybe I think we have time for the last question. One or two. Are there any questions?
Hello,
Yeah.
Mr. Bharat. Just to have an idea, what is the overall rejection percentage of your plant you're operating?
Yeah, see, basically in sand foundry, I would say the double digit is not really surprising, but for us, it's a single digit.
Okay, thank you.
This was the customer question, huh? Okay, Uwe and Johannes, is there anything, any question? Or Johannes, as I said, wie schon gesprochen, 50 Minuten habe ich schon die Präsentation beendet.
Perfect, Bharat.
Yeah, thank you very much.
52 Minuten, 52 minutes, 2 minutes was taken by Johannes.
Punktlandung, as we said in Germany.
Okay, so it's nearly midnight.
Yes.
For Indian people. And
so maybe I think if there are more questions, I can share your email address, or the audience can contact you by email if they got any questions.
Sure.
Yeah. Also, you got a LinkedIn profile, so we can join your network on LinkedIn and contact you. Yes. Thank you very much, Bharat.
Yes.
Thanks to the audience. And I hope we all see us at the next Aachener Fachgespräche in February.
Sure. Okay.
Yes, thank you very much. It was nice to see you, Bharat. And, yeah,
Yeah, Toro.
all the best
Yes,
for
and
your business. Yeah.
thanks a lot. And to all Indian guys, if you want to join us for the next time, please do that. And yeah, have a good time and stay healthy, please. Bye bye. See you.
Thank you very much. Bye bye.
Bye bye.
Nice
Bye-bye.
evening. Bye bye.
Bye.
Thanks a lot.